Okay, on the agenda, you will notice that it doesn't have this title, and it only has my name. When I originally put this in, I put it in for both of us, but my name was on the proposal, so we changed the title because we felt like it.
Right. And this really isn't about building desktop applications per se, although it can be used to build applications that run on a desktop, but they can actually run anywhere. But really it's about taking Ruby and the libraries that come with Ruby and making that deployable, which can easily be a desktop app. But I just want to let you know, if you think we're going to go up here and do GUI programming and everything like that, and like, woo, look,
how many did think that, by the way? Raise your hand.
Okay,
Sorry.
You guys can leave. No, I'm just kidding. This is really good, though. It's actually more important than building GUIs. So.
Yeah, I mean, you could use it to build GUIs.
So
but we're not talking about that.
We're going to start.
We're going to start. So
Animation.
Oh, yes.
Yeah. We don't have a lot of content, so we're going to
so
rely on Keynote to do a lot of what we're doing here. So.
We had flames and stuff like that, too, but we took that out. That was ridiculous. Sure, we can talk later. One of the questions that comes up when you're talking about doing this is, why are you doing it? And why are you using this particular set of tools, which we'll go into? And why aren't we using something else? Joint Slingshot comes up quite often, which is specifically for Rails. So let's talk about that a little bit.
All right, so why did we do this? This started from a project which, I don't know if you've got a history slide or anything like that. Well, wait, it's got a...
Bye-bye, we'll come back.
Okay, so a little history. My company, InfoEther, in 2005 started a project called Indy, which I actually presented on the architecture at last year's Ruby conference. And part of that was, how do you package Ruby for a desktop application? In that instance, the desktop application was a Ruby app, and the UI was actually written in Flash, and we wrapped WebKit on OS X and IE on Windows, and so it looked like a desktop application, but it was really just a web service thingy.
Right.
Anyway, but one of the things we had to solve was, how do you actually package Ruby for redistribution, where you want to take the libraries, your source for Ruby, and not necessarily open it up to everyone. So you want to send that out to people, let them install it, effectively have a couple of files.
Yeah, and actually I think maybe that's even more important. It isn't so much the open up, it's not so much the IP in some cases, it's just the fact that Ruby's just a lot of files. It's just
Right.
a lot of stuff all over the place.
Yeah, all the Ruby source files and standard distribution are very large. So what we needed to do was package that up so that the executable had a file, and then all the Ruby source files were another file. And that's kind of where this thing sprang from. We then took that. 5 Runs had a client. You can talk a little bit about what that client was written in. Originally, it was in a different language.
Yeah, I'm not familiar with that. Oh,
Java.
sorry, what's that? Sorry.
Java, right.
What's that? Sorry, didn't hear that.
So they had, the 5 Runs client is really the thing that you install on your server
Right.
to talk to the 5 Runs infrastructure, which will then help you monitor and manage your server.
Yeah, we'll talk about why we decided to move into Ruby, besides the fact that I'm not familiar with that language.
Yeah, and they built a almost Turing-complete language in XML too. So
yeah, but that's
anyway,
story too.
that's something separate. So what we wanted to do was use Ruby to replace that Java client, use a Ruby client. It's much smaller, like way smaller,
Yes.
to have a Ruby executable and then all of the source Ruby stuff in a single file. And that's kind of where we started at with this, talking to 5 Runs. So this presentation actually is, we're taking the work that we originally did in Indy, then the work we're doing with 5 Runs, and we are going to extract out of that what we're going to be talking about today, and open sourcing all of that, so that people can actually package Ruby and applications on top of Ruby very easily. But
Right. And actually, how many people here were here in Denver, or not here in Denver, but in Denver last year for this? If you remember his Indy talk, it was pretty cool. So we're kind of basing a lot of our infrastructure on top of that same kind of infrastructure, which is kind of neat. I think I've got a gratuitous effect. We need to go back to why. Do you want to bounce again?
no,
We're done?
no, bouncing. We're done with bouncing for now.
I think I've got this one.
Oh.
Sparkly. I think that's the last effect, sorry.
So the basic concept here is to take Ruby, all extensions for Ruby, and everything else, and statically compile it, so it's a single executable. And then the effectively change require and load so it loads from what we'll call a virtual file system, a file system inside of a file. That file system is zlib compressed Ruby source. We actually encrypt it as well, and all of it's stored in BerkeleyDB. And we talked a little bit, I don't know if we have a slide on this, but the reason we chose BerkeleyDB is it's actually very small. The native extension for Ruby is just C, and so that's another reason we did it. Talk about that in a couple seconds. But this is the basic concept. You put all the files, all the Ruby source inside of a BerkeleyDB file, and of course Ruby's all statically compiled. So with these two things, it just works. Did you have a question?
Oh no, that extension in C.
What's that?
The Berkeley extension. Who wrote that?
Oh, we'll talk about that in a couple of minutes. But the no, require and load is actually done in Ruby, which you'll see.
Yeah, we'll go into that with those infrastructural.
No, we didn't write any C code. Well, we did a little bit of C code to actually build Ruby statically, and have a little bootstrapping logic. That's about it. But this is the basic concept. You have Ruby, you have this virtual file system inside of a file. That's your whole app. You drop these things in a directory. You can run them. It runs out of there. Life is great.
Right, and you can mix and match, too, whether or not the run out of stuff is being loaded from the virtual file system or from the actual
file system.
Right.
Especially for like development mode. You want to develop out of the file system and then be able to package it up real quick, test it that way, and then deploy it. So that's kind of the development lifecycle.
Right.
And by the way, this includes Rails apps.
Yes,
you can actually package up Rails apps this way and run them out of there.
And that's the new Indy does that.
Yeah, we're going to be doing that.
So, and I think it's worth qualifying, even though it may be obvious since we started this back in, since you started this back in 2005. When we're talking about Ruby here, we're obviously talking about MRI. So.
Right. So I don't know if anyone here has had to statically build Ruby before and its extensions, but if you get the Ruby source distribution, there's an ext directory, which is where all the extensions are. And there's a setup file there. And in that setup file, and there's different ones for different platforms, but the basic setup file, if you look at there's a couple of Ruby commented lines in that file. What's really odd is this is actually Ruby code, although it doesn't look like it's like almost maybe the first DSL ever written,
Maybe.
But anyway, so this says hash options no dynamic. If you uncomment that, this is kind of odd, right? Reverse logic. But if you uncomment that, you will not be able to load extensions dynamically. So you won't be able to load .so files, right? So you can effectively lock your Ruby runtime that says don't load .so files as extensions. You can still use things like DL to load them if you statically compile DL in. But Ruby itself won't, load socket.so, for example, things like that. Then what you do is you go through and there's these lines, and there's like 30 lines in it if you look in this file, and it has like big decimal with a hash in front of it and all the different extensions. You just uncomment those, and they'll be statically built. Instead of making a bunch of SOs, it'll all just be statically compiled into Ruby.
And so you can mix and match those too. I mean, you could leave the options no dynamic commented out, which would still allow it to use dynamic linking, and then underneath you could statically link ones that you want to. So, and that actually happens for some platforms already.
Yeah, there's a lot of things that are statically built in a lot of platforms, actually, like on NT and things like that.
Right.
So there's a couple of gotchas here. There's a couple of gotchas. When you statically compile, if you want this thing to be really self-contained, if you want this thing to be really self-contained, you have to make sure that when you statically compile that extension, that is actually compiled or linked against a static version of that library, like OpenSSL, zlib, anything that you want to actually include as part of this thing, so you have really no OS dependencies, or you're locking at least in on a version. And on OS 10, even if you try and statically compile, if there's a dilib out there, like BerkeleyDB, if there's a dilib out there, it will link against it. It will fight you to make sure it links against it. So when we actually build our runtime, we actually have to get rid of or temporarily hide the dilib files so that we make sure that it actually gets the static library for things like BerkeleyDB. Don't quite know why that is, but Lauren and I, I'm sure, will be able to talk later, and he'll be able to show me exactly why that is. No, he's shaking his head no. Good. So just watch out for this. If you have any dilib files, they'll dynamically link against it, and then what will happen is you'll try and run this on another computer, and it'll say you can't resolve that, and life will be bad. So that's just more of a gotcha. So let's go ahead and talk about a couple of the runtime libraries that we include in this.
Yeah, that's necessary for this to actually work.
So one of them is BDB. So this gets back to this Berkeley DB extension. And that was written by Gitaku. Anyone here not know who Gitaku is? A couple, you need to leave. No, you don't. I'm just teasing. Gitaku is a person that has anyone ever met him? Isn't that the oddest thing? Probably one of the most knowledgeable people about the Ruby's internals in the world.
He's like Batman.
No one has ever met him.
Yeah, it has been posited that he's actually a bank of supercomputers. That's right.
Right. An AI. Yeah. So, but Berkeley DB is a C extension. It's only written in C, and what's nice about that is so that statically compiles in. And when you statically compile in an extension and you require something like Berkeley DB, it's already in memory. It's already in the namespace, so it doesn't have to do anything. So the static Ruby, when it starts up, just like you have file out there without doing anything in Ruby, you'll have BDB out there. If you statically compile in, we do zlib and OpenSSL, those things will just be in the namespace. They'll be kind of pre-populated when Ruby starts before you do any require and load. Yes?
I have a question about that dilib thing. That's generally the case when you try to compile stuff in OSX, that if there's a dilib out there, it'll try to compile against it?
Yeah.
So your solution is to
Move it.
temporarily, go look for...
Yeah, it's lame. We renamed things.
I think there's a bug people are having with compiling MySQL that I think might be related.
Oh, there you go. It's all
So is that the architecture bug, the building
Well, there's
universal
that.
bug on buffer?
There's that, but then there's another one where it throws... Yeah.
Right.
Okay. Well, there, maybe. But zlib and OpenSSL. So what we were trying to do here is we want the native Ruby, when this thing starts up, to have enough in it that the overwritten require and load have everything they need to be able to reach into this Berkeley database and pull everything out, right? And we wanted that to be written in Ruby. So those things have to basically be in memory before we do a require and load. And all of these extensions, once statically compiled, are just available. There's no Ruby dependencies, which is handy.
Yes.
Yeah. No.
Next.
So that's
Okay.
the core runtime libraries.
This is probably the big slide, at least in how things actually work.
How it runs. Go ahead.
Okay, so there's a couple things here. There are essentially two builds whenever you have this. You're developing one of these runtimes. You have two builds. You have a development build and you have a production build. The development build is a little bit, there's less built into Ruby. We'll talk about what goes into the production build in a second in more detail. But with the development build, you essentially have just a statically compiled Ruby. And you can run in two modes. You have a mode where you want to run off of the existing file system where you're actually developing, which is probably lib or somewhere else inside that structure. Or you might want to actually dump all of that into your virtual file system, into your database files, and actually run from that. That's specifically really good for testing.
Yeah.
So the way this works, and Rich can go into more detail about exactly how everything goes when we go into the code here in a little bit. But the way it actually works is when you run the script to either run from one or the other, it generates this start.rb file, which Ruby is going to, the statically compiled Ruby is going to look for to start up once it runs. And that's going to define, we'll go through the configuration again later, but that's actually going to define what to start up once that goes. Now with the production build, the production build is a little bit different. Since this is what you're going to actually be giving people, we take all of that startup code that involves how the virtual file system is accessed, the monkey patching that we'll talk about here shortly, which we love, and
It's beyond monkey patching. Right?
Yeah, it's beyond monkey
It's
patching.
like dynamic source patching. What?
Not very big.
There's no ducks yet. Okay? I mean, if anything, it's string right.
And I'll leave you with that little bit of knowledge. Okay,
Nice
so
word picture.
yes, thank you. Someone actually bought duckrate.com, I think, yesterday. So see about the production.
Well, no, so what, with this, what it does normally when you want to run things out of the database in the developer mode, it just forms the start.rb, which has everything that says pull everything out of the database. That generated Ruby script in the production build gets turned into a constant in C, and then is actually compressed, and then is when Ruby starts up, it evals that string in Ruby. It actually just starts up the Ruby interpreter and then takes this big constant string and sends it into Ruby and says, do your magic with this thing, which it packaged up when you statically built Ruby. So your production has this kind of bootstrap code in it, which configures it. And including things like passwords, if you have passwords set on that, I know it's kind of lame, but this is not like ultimately secure code or anything like that. This is just keeping honest people honest and whatever. And anyway, so all of that is packaged into this thing and eval when that Ruby starts up. So really when that starts up on the production side, you just have Ruby as an executable with this thing statically compiled in the bootstrap Ruby code, which includes the overridden require and load, and then that effectively starts pulling things from the database, and life is good.
Yep. And we'll actually go into that right now, what's actually inserted in there. So there's 3 bits. 2 bits are part of the runtime that you never really have to touch if you're developing these applications. And the third one is your configuration, which is, we'll talk about that first, and then we'll go into the more complex stuff on top. But that is, the file systems.yaml is your configuration for what databases you have, what paths go into each database. We let you break that up so that you can replace a database quickly if it's a small one, so you can separate some pieces of your code from the larger chunk with Ruby standard library, which is also built into these databases.
Yeah.
And then the init.rb, which is the actual startup code for your application, which defines what the actual entry point is for your application. So, and Rich will talk about Runtime and kernel X.
Yeah. So Runtime is kind of this virtual file system. And the first thing we do is we have this I/O capture capability. When you're running a kind of production app, let's say you're running this thing as a .app on OS X, which we can support. If it's a .app file, all standard out, standard error, and everything like that go to console, right? What I/O capture does is capture standard out, standard error, standard in, or standard everything.
Standard everything.
Yeah, and redirects them to a log file. So you can capture that log file if you want. You can also just redirect them to kind of capture to nowhere if you don't want any output
You can
on that.
go to different files as well, and
Yeah.
you just won't have the weaving.
Right, yeah, exactly. It has this virtual file system, directory and file. So we have the concept of this file system, and then we have a concept of directory and file, as in dir and file in Ruby. And these things kind of behave like dir and file in Ruby. And we monkey patch require and load to actually use runtime. So the kernel extensions that we do really just override require and load and kind of turn on the virtual file system thingy. And require and load, by the way, first look in that database. If it can't find it, then it goes to the normal require and load. Right? Goes back out. But yeah, no, actually it doesn't. I take that back. If it doesn't find it, it raises a load error. So the point of this is to be encapsulated. It's not going to go to the file system and actually look for other Ruby source files.
Right. Although there can be some files that aren't built in.
Yeah. Right. So anyway, patches require and load works with the virtual file system, and we'll actually show you those things as code in a few minutes. And
Yeah. Okay. So let's talk about the basic structure that we have set up right now, at least. So these are the main directories that are inside one of these projects. One of which is Ruby, which is just your Ruby source, which if you have any additional native extensions that you want to statically compile in, that's where you would put them. We're working on a kind of an automated build process.
yeah, that's the thing that's holding up us releasing this right now. We've got like Ruby code, but the thing of building Ruby to compile statically across OSs, we're trying to target Windows, Mac, Linux, Solaris, FreeBSD, so that we'll have these kind of rake scripts that you'll be able to run against the Ruby, pull down the Ruby source. It'll set up the extensions, and it will build Ruby for you. It'll build this directory for you. This is really the Ruby source. So this isn't like native extensions in that. That is actually all the .rb files that exist in Ruby. And then you've got your runtime directory, which is the stuff that we use to manage the virtual file system.
This is where the kernel extension and the
Yeah,
runtime.rb
that's just
sit.
that. And then the lib directory is where your stuff goes, but it can go really anywhere. This is more convention, but you specify that within the YAML configuration file
Right.
of
You
where
can
your
add
stuff is.
You could add an endpads, whatever you want.
Right.
So we'll talk a little bit about the virtual file system format as well in BDB and what it is.
Virtual file system. What we do here is, Berkeley DB supports 4 or 5 different types of things.
Yeah, B-tree, hash, what's the other one? B-tree, hash, recnom, and another one.
Kinds of weird things. But a recnom is kind of like an array, effectively. And what we chose to use array in this so that we could quickly load up all the keys and munge the keys. So record 0 is a hash that contains all the file path. So when it's building this database, it's recursing over these directories, it's getting these files, it's building a hash that says this file is in record 1, this file is in record 2, this file is in record 3. So this hash contains all these file names to locations in the records where these things are at. And that, when it starts up, it loads that index in memory.
It's essentially your load path.
Yeah, with all the files that exist in this path. It's marshaled, compressed, and encrypted. And then each record is compressed and encrypted. So we're using Z-lib compression on everything, decreases the size of Ruby source pretty dramatically.
What about the speed in terms of loading these?
Yeah, this is actually, these things load, I mean, Berkeley DB is pretty fast as a data store. And so we found that loading a whole bunch of Ruby files is actually faster pulling from here than it is just pulling from the file system.
So,
What's that? Even when uncompressed on the way in. Yeah. Yeah, and encrypted. So, I mean, the encryption and compression overhead seem to, still not be up to pulling from the file system and everything like that.
yeah, they actually have negative overhead. It's kind of nice.
Yeah.
That's a patent that we're going to come out with later.
Yeah. So this is kind of the crux of this virtual file system format. And at this point, what I wanted to do is kind of jump into the code, which what we did is
God says no.
Yeah. What we did, I mean, we're actively working on this with 5 runs, my company InfoEther is, and so we're, this is like real, live code, as in we're currently actively developing on 28 minutes ago.
Yeah.
And we were trying to get something working that didn't quite work, because some of the old Ruby code does some existing Ruby code, does some very interesting things. And one of the things I want to talk about, well, I'll do it as I kind of go through the code, talk about the whole way things can be encapsulated or not.
Yeah. In short, they do very traditional, I guess you could say, file I/O, using some things that we generally don't use these days.
Like, they don't do file.open, right? Or, they do open, which is in kernel, that's fine, But it's harder to
like that.
actually work with some of that stuff. Anyway, yes? It's kind of munged and embedded in the C compiled.
Right, and that method can differ, however,
Yeah.
I mean, that can change.
We could extract that, but
You can only go so far. I mean, you just have to go
Oh,
far
ultimately,
enough
it
that
doesn't
you can
really matter,
litigate,
right?
I guess.
Somebody will figure it out.
Technically.
But I'm going to go ahead and go to code.
Sure.
Cool. So, demo. Nice. So the first thing is, this is the directory structure we were talking about. We have this config directory, which we have a file systems YAML file, and this is a nice big encoded string, which is an AES-256 password, which we randomly generated for this demo. And so just don't memorize that real quick, and because it's actually a production key. Teasing. Anyway, we have a primary
key that will change.
Yeah, we have a primary and we have a secondary database. The primary database is, we said we want to have for things like Ruby, and so we call it Ruby database right now. And then the paths to include in that are the Ruby directory and the files version. So this is just a file I have here which has, don't drink water,
Hates water.
which has a number, and it has the version number in it. I mean, you can actually just append as many paths as you want, as many files, individual files as you want. And then the secondary database is what we call application database, has like lib and public and encapsulated paths. I'll talk about in just a second. But lib and public, these directories are going to be recursed. So I've got my lib directory, which has a test file in it, and I have a public directory, which has a couple of files in it. And these things are going to be loaded up into the second database. The concept of breaking it apart is that you can actually read and write from this virtual file system. So you can actually write something back into the file system and read stuff out of it. And what I wanted to do, and the reason we broke them apart, is so a lot of things don't change ever. Like you're not going to necessarily change Ruby 1.8. If you are, then you'll ship a new RubyDB down to people, right? You'll update the system by shipping a new RubyDB. But that file's like, I think 1.3 meg or something like that with all the source in there. So you don't want to do that all the time. But the application database could be really small. It could be 10, 15K, right? So what's nice about that is you could actually do really small updates by just updating this application DB and just go, just drop it in the file system and you're updated. Your whole app's updated, everything.
Right, and for 5 runs we use that. We have that
Yeah.
for plugins specifically so that we can update plugins very quickly and you don't have to ship.
Right. Encapsulated paths say everything within these two paths, so anything under Ruby WebRick, anything that kind of begins with that, or anything that begins with lib, is encapsulated. What encapsulation does, I'll look in this file here. Can people see that back in the back? All right. All right. So let's say you do something like this, right? Say hello. Version is file, read, file, join, file, dir name, __ file, right? Wonderful looking. Okay, so I didn't actually used to do all this stuff. You go into the Rails source base, and this stuff is all over the place, right? So they're like, oh yeah, everything relative to this thing, up to directories, down at there, then back forth over here, and then that's the file you want to load. All the things under there. So you got that. And they do this a lot, which I'd never seen before. I looked at the Rails source code. That's okay. The problem with this is if you're bundling all this stuff up in the file system and you're doing things like dir globs to load other Ruby files, so you want to say, I want to iterate over all these things relative to where I am, like we do with the plugins directory in the 5-run stuff, and I want to glob all the things that are under there so that I can actually require them or load them, right? So it's a very common thing Ruby people do. If all this is in the database and this file's in the database, then when you do file read and that stuff's just in the database, file read won't work, right? Because the files aren't in the file system anymore. So if I were to actually, if I were to do start, it's going to run, it says hello from version 1, disregard the debug output stuff. And really, if you look in init, all init does, this is the init script that Bruce talked about. It requires test, so test has to be in the load path. And then it does test say hello. So this is the required test, and it does say hello. So all it does is says hello from version 1, and all this line is doing is loading the version file by going up a directory from the location of the test file, right? So you go up a directory, which is in demo, down here to version, and it reads that in and it says hello from version. So pretty simple. That's all that does, and say hello. And when I ran it with that OS 10 thing, it said hello from version 1. Now again, if you were to run this from this code, we saw right here, yeah. So if you were to run this from within the database, it wouldn't be able to find all those files. So you could actually sit here and go, oh, all we need is selector namespaces, and we'd be okay. Right? So if we had selector namespaces, then we could change from this thing what file and __ file and everything else mean. But unfortunately, we don't have selector namespaces in Ruby yet. So the other thing people say is, well, why don't you just patch file? Monkey patch file, like people do, right? Just monkey patch file so that when you do file read, it reads from the database instead of the file system. The problem is, what if you have code that you actually want to have read from the file system that's in the database? You don't want to change what file does, right? So the concept of encapsulating, if you look in here under this, these encapsulated paths says everything under this path is going to be encapsulated. And what encapsulation does is this set of strings here, this is just a string. So all of that, which is written into the database, one of those records, is pulled in. After it's pulled in, all the references to, we have these really nice regular expression things that go through the code, and it looks for things like file, dot, endur, dot, endur, colon, colon, file, colon, colon, because all kinds of weird ways people call things. And it actually replaces those strings in the code with db file, db dir, and underscore underscore file is actually replaced with the file path that's actually in the database for that file. So effectively, this code, once it's processed, looks like this. And then all the way down under, then this one's replaced as well. And then under here, this is actually replaced with a string, which is the file. And so we're monkey patching the source before it's ever eval on the way in. What we've done is we've switched classes, right? I mean, by changing the source, when it's evaled, it actually doesn't say file. It says db file, and db files are a class. It's in the virtual file system thing.
Right, and you've done this to Rails.
Yeah, by the way, this works with Rails. The entire Rails source code, if loaded in this thing, you can run it from the file system, and you can actually load it up in a database, and you can run it, and it will patch the entire Rails source on the way in, and it works, all of it. Now, you can also have unencapsulated directories. Yes.
Yes, that's actually what
We're doing.
they're doing.
What's that? No, at runtime, it patches it on the way in. It could do it when we built it. Yeah, it could be. It's actually really incredibly fast, but we could optimize it by doing it.
There's concerns too about when you write to the database later on.
No, I mean literally when you're building it, you
whether or
could
not
patch
you're
the
doing it
source. But yes.
Like a hack? Yeah, it is. It's a dirty hack.
It also sounds potentially error-prone. Have you considered just setting up a module that redefines file and dir and that sort of stuff, and mixing it in?
The problem is if you actually want to use file and dir.
But in every case where you're doing the patching, you're patching it.
And then you shift the namespace for where things are by putting it in the module, right? Yeah, I mean all the files would have to be.
You still have to do string patching, but you're not searching for individual things. You've got your one module that's got the patches,
Right.
And you just throw that include into.
Yeah. So or maybe not. Well, actually include. Can't do it as a method. So it would actually have to be in a module, or the module would have to be available. The constants would have to be available inside of where this is, right? So in other words, where the scope that where this thing is loaded would have to have the file constant available in that scope of where that's.
Every time you have a class line, the line that has class tester or a module line, you just have right after that include my hacky patch module.
I don't know. Well,
Underscore file.
yeah.
Override const missing, get rid of or move the file somewhere else, and then check columns.
Yeah, that's not good.
Well, we're not done here either. So.
Right. Yeah.
I mean, there's definitely room for improvement, and that's one reason why this is going to be open source.
Yeah, because I think we could all benefit from that. What's wild is we did this, and it works. And it works well on something as complex and that is heavily file system dependent, like the Rails source tree, just works.
Which you didn't write.
The Rails source tree? No.
Exactly. So, I mean, and when you do have code within your control, you're aware of the
Yeah,
constraints you have as
yeah,
well.
and that's important. So when you have code that's in your control, like I could have another directory with code that is not encapsulated, then if you want to use the database, you'd use db file. And so it creates those constants. And then if you want to use file. So non-encapsulated code can actually use both if you write it yourself to do that, whereas encapsulated code. Now, I'll show a little bit of how I had to do that. It was really a pain in the rear end to get this to work. And I did it specifically for Rails at first, but we're generalizing it more and more. What I want to do is, right, yeah. Well, before we go into runtime, let's actually show this. Now, the next thing to do is I've got this thing, and I'm going to do build database. And that's going to load all the Ruby stuff and put these three files inside the application database. I just have it printing out right now. So libtest, this public, and this file are actually in there. There's 537 files they're in the Ruby DB. And then if I start from the database, it says hello from version 1.0. Now what's interesting about doing this stuff at runtime, you talked about doing it at runtime versus build time. If I go into this YAML file and I actually unencapsulate the lib directory for fun, and I run this, it'll say it cannot read version, it doesn't exist. So what I did is I didn't wrap that, which means that that source, back away.
Hands in my pockets.
Yeah, that source did not get patched, so it couldn't find that out of the database, and so life is bad. So the encapsulation stuff, being able to switch that out of whether something's encapsulated or not, to do it at runtime gives you that flexibility that's kind of external from the database that you've built. If you do it at build time, then it's forced. I mean, it's always going to be patched that way, right?
You have to rebuild everything.
Yeah, you'd have to rebuild the database every time in order to change what you're encapsulating. Here, you don't change that. You actually just change this, and you can test it out that way and figure out what you need to encapsulate and what you don't. What we were trying to do in this demo, and which we failed to do, and I'll actually show it running because it's kind of funny. We actually, I think it's called Start Web Brick, right?
We did this over lunch.
It wasn't even lunch.
Yeah, it was after lunch.
Actually, there's a point B. So Start Web Brick, and in the test file, if you looked at that, Start Web Brick tried to run Web Brick, and it tried to run the document root here. When you do this, and then I'll just try and do this stuff here. Of course, my browser's going to be. So I'm going to just run it normally like this. Web Brick starts, and so let's go into the browser, which has a relatively large window. High resolution Macintoshes are great until you plug into an 800 by 600 screen. So you hit that and it says this is a test. That's what's in that test file. This is running against a file system. All is good, right? So you do that. Now, this is actually running from the file system. It is, and you want it to be encapsulating it. But what I'm saying,
it's not even going through that process.
When I do this OS 10 start, this is running from the actual directory structure.
It's just like
it's not actually using the encapsulation or the patching or anything.
Or the
kernel
database.
Extensions, none of that stuff. There's no database involved. Uh-huh. Yes. I can't actually hear you now because people are clapping. It will once we start this up patched, and that's exactly what we want because we want to ship our web directory inside of this database so that we can actually deploy it. Right? This is kind of like the Rails thing, have the public directory and stuff like that. By the way, Mongrel can be statically compiled into Ruby too, so you can have that. It's kind of nifty. But we got this thing to this point where when you run this, I'll rebuild the database real quick. So the database is rebuilt. I'll start it from the database. WebRick starts. And then when I reload this, it's a string IO. Cool, huh?
It's our fancy demo.
That's our fancy demo. It was supposed to be the actual string, because what we do inside is, in order to give things IO objects, we build string IO objects off them. And WebRick's probably doing something like IOs automatically turn themselves into a string under certain circumstances, and we're depending on that capability or something.
This is one of those going through old libraries and figuring out how things
work.
Monkey patch isn't complete at this point.
Yes, especially with this. But I think we're very close. I mean, we didn't have to change WebRick at all in order to make this work. But we only got to this point, and I think we can figure it out even more. That's for that, yeah. So the other thing that I want to show is some of the actual stuff that we had to do to pull this off. So inside the runtime directory, we talked about like the kernel extension. And we'll close that for a second here. And that's the stuff we were just working on. We had to create that just a couple minutes ago. So this is a require and load that get, the original require and load go away, and it gets replaced with this. And this require does this, database runtime virtual file normalize the path This is because sometimes you have these paths that are like, slash, this slash this slash this, dot, 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 slash this, right? And so I normalize the path so it looks normal and it can actually be matched against a key. That's what normalize does. And then it checks the, dollar quote is loaded features. So it checks to see if the path to this thing that you're actually trying to require has already been required. It checks loaded features to see if it's been required. .rb, .so, or the path itself. And unless it's loaded, it actually goes to the virtual file system, which is just a constant created in kernel, which is the instance of the virtual file system, and it reads the file and the key. The key being, because it actually traverses the load path, this honors load path, so if you have a bunch of load paths, it'll actually walk the load paths and try and find it. It returns back this key, and the key is really where it found this thing in the load path. And then the data is the actual data itself. If there's data, it appends it to its loaded features. It evals that data with that key, saying it was loaded there, and it returns true. Otherwise, it raises a load error. And then load doesn't have to check the loaded features thing. It just goes and loads and reloads that file over and over again. And that actually works. And what's nice here is when you get exceptions, because you're actually setting things like the actual file name and the line number being 0, you'll get regular exception stacks that actually tell you what files are in, even if it's being loaded out of the database. So the stack traces are actually usable. That's why you do these sorts of things. The open is just trying to, this is our incomplete aspect of it. When you actually use kernel's kind of open methods, the I/O methods that are on kernel, we're going to have to kind of override or patch those things too in case things use those directly instead of
in a better way than we are right now.
Yeah. And then virtual file systems actually creates the virtual file system with the options passwords. And that was pulled out of that options YAML file. And it opens the database, the primary, and the primary database, the secondary database.
We're going to support N databases.
Yeah, so you can actually split your app up into N, where N is more than 0. And your encapsulated paths, it just does those paths or an empty array. It sets these constants up. DB file, dbdir, virtual file system. This may be pluggable as well within that config file. And if you have the log configured, then it captures all of your output to that log. So this is the thing where you said you want to capture your I/O for this thing that's running out of this database. And so that's the kernel extension. So now let's go through the frightening file. Now these builders, by the way, the start builder and database builder, the database builder builds the database. And that's going to be refactored to be a nice set of classes with methods that are tested. The start builder builds your start file when you're doing development. It's actually something with like using opparse that you can actually run. It's an executable Ruby file, and you can pass it parameters to say, build me a start file to run out of the database, or build me a start file to run from the file system, and it knows how to do those kinds of things. The runtime is the crux of where everything is done. And what we had to do here in this is, there's our I/O capture stuff, but the virtual file system opens the databases, and this is where you're actually opening, using OpenSSL and all these types of things. All this stuff occurs before, I see. That as in, 5 minutes. It opens this up, and it's using all of these things that are statically built into Ruby. So this is really nice. So require and load don't exist yet, effectively. And it's opening these things up, the 2 indexes, and then it reads the files and keys, and this is traversing the load path to try and find things. This is where it's G-subbing things in here. This is our nice little source patching mechanism, replace references, and replace references on these virtual files and virtual directories. Probably not put some source code, sorry Marcel. This is heinous stuff. And you can do things like set a key and a value. So you can say, I'm going to write this file. So if you do virtual file system, open square bracket file, close square bracket, equals whatever, you can actually set a value and it stores it in the database. And right now it's storing it in the secondary database, not the primary database. And the virtual directory. So this is really the crux of the hard part of doing this whole ability of patching dbdir and dbfile. There's a bunch of places in Rails where they're using all these file and dir methods directly, right off the class dir and file. And What these do is these effectively replace all of that. And probably the hardest one is glob. You would think that glob would be able to be something as simple as using FM match. I don't know if anyone's looked at file name match. It's not. Glob actually behaves differently than FM match. When I first saw it, I'm like, oh, look, file name match, awesome. It's right built into dir. I can just fall back on dir and do it. It doesn't work. So glob is very different. And so this actually is a glob implemented in Ruby. And it performs glob on file patterns that are in that list.
In that record 0.
And record 0, yeah, against that. And virtual file, disregard that stuff up there, this does all these things on file, like FM match, dir name, directory. Is this file a directory? Expand list, normalize, extension name, all these things. A lot of them just fall back to file.that. I mean, obviously exist goes, do the keys include this, right? FM match just falls back to that. And so a lot of the things we just kind of pass through. Some of those we don't. Deleting. But I didn't actually want to delete here yet. But that would actually delete from the file or from the virtual file system. Exist. Join. And then we did things like open. And this is the thing where we do the I/O. When you open on a file, we just assume that it's always going to be open. And we don't yet support file writes. I mean, you can't open a file for write and then write into it and write into the virtual database yet. Try and see if we can figure that out. Like we said, it's incomplete. Read just reads that up. And file symlink, things like that says no. And then stat is a thing that we've been experimenting with because things in WebRick were using stat a lot directly. But what this does is this thing looks like it duck types, right? So it kind of looks like a file. And so if that source is patched, it actually just runs against this, and magically it all works. And again, the entire Rails source space will use this. I mean, we run this with our app that we're building, and it works fantastically. We have probably 15,000 lines of code or something like that, and it works great. 5Run app has been working great with this structure. And, but we want to open source this aspect of what we're doing and get people to iterate on it so that we can actually have things like automated build systems that will run on different OSs that can be submitted. So that if you're on an OS, you can say, I want to automatically build this for this OS. And people can give us all kinds of cool patches to make this thing like totally complete.
Yeah, it's a robustness thing.
Yeah, exactly. And we want other people to be able to benefit from being able to have redeployable Ruby apps where you just like give somebody an executable, which is all self-contained. They actually don't need to have anything installed. Like on Windows, you don't have zlib, that Ruby uses. You don't have OpenSSL necessarily. So to be able to statically compile all that stuff, and by the way, Ruby statically compiled with all this stuff on Windows like 1.8 meg for everything, right? With BerkeleyDB, OpenSSL, zlib, everything statically built in. With Ruby 1.8, it's like 1.8 meg. That's tiny, right? And that could actually be a graphical app if you want to have it. You double click on it and Ruby starts and you've got this thing running, the graphical app. It doesn't make Ruby thread safe or anything like that, but you'll figure that out with no problem, I'm sure. And that's kind of it.
Do we have time for questions at all?
Yes, we do.
Let's take some.
Time for questions.
Yes.
Sorry, I sort of missed it. For things like files that are created while this app is running, are they actually stored back into the BerkeleyDB, or do you store them in the local file system somewhere?
You can do either, depending on what you're doing.
Yeah, I mean, if you write the code yourself, and it's not what I call like magically trying to encapsulate,
It's not encapsulated yet.
then you can read and write into that BerkeleyDB yourself just by using dbfile and dbdir instead of file and dir. If you want to write to the file system, you can. Just say file and dir, and it'll just read and write to the file system, so you can do that too.
So what about an example like Rails, like where the log files are stored? Would they actually be stored in the local file system where this app is?
They actually get
Right now, they go into the database, right?
Okay.
right now they do.
Right now they do, but there's a lot of configuration you can do. You can, a lot of stuff you might actually be able to configure in your app.
Yeah,
the Rails app
with
to
the
run
Rails
outside.
app itself, it doesn't write the log files in the database. We actually turn off those.
Okay.
Yeah.
And when do you think of be open sourcing this?
Soon? I mean, really, what we want to do is get a couple of automated builds working on some of the platforms as a starting point.
We've been working on a really interesting method of presentation-driven development.
Yeah.
The last few days, we made a lot of headway. So
If you're trying to present something, you actually refactor your code to make it presentable.
So you fix problems.
That's like the agile conference-driven development.
Is that right? Yeah.
So if we were to use this for deploying an app to someone who you consider maybe a hostile customer who would want to steal your code, would this be appropriate in terms of security?
Nothing's appropriate.
I would recommend not working with hostile customers.
No, I'm very serious, right? I mean, anything you build will be thwarted. Actually, it's protectable under the DMCA because you can just sit here and say, this is a method that I'm actually using to try and protect my IP. And if they go around that, you can sue them if you want. So at the end of the day, that's all you got. I mean, you have nothing that will protect yourself. There's nothing you can come up with unless you can, in which case that's awesome. Like, we don't have quantum cryptography yet implemented, but we're working on it. There's nothing really that you can really do to protect your code if it's on somebody else's machine. It can be cracked. Just in general, right? So
Just
this,
a level
this
of
to me,
difficulty.
this is encryption. It has encryption with keys, and if somebody looked at the code, they would be able to figure it out. But they could decompile the C code or dynamically use dtrace to reach inside and do things and look inside the runtime and get the password out and then go in and actually extract the database. And it wouldn't be terribly hard to do that. And you could make it harder and harder, and all it would be is just harder and harder. And then somebody would build another script, it'd be easier and easier. So that's just the route, you know? That's just life.
Jim.
Totally. Yes, it prevents stupidity. Kind of.
Are you a user interface guy?
That it would have if we would have had that finished. Given 30 more minutes, it would have.
Yeah.
Yes.
Yeah.
You would actually have
Walk
seen the
through it.
directories. Yeah.
I'm curious about your YAML with the decryption password. I assume it gets
Yes, it does.
put somewhere else.
Yeah, what happens is when it generates that Ruby script, which gets then injected into the C file, it's actually munged on the way in. And then, so it's not plain text in there, right? Yeah, it's a big region inside your C file which says password here with big bars on either side.
We renamed the application your password, which is really handy.
That's the, no, but yeah, it does that, and then that big script is effectively eval.
So.
It reminded me of, media companies trying to put keys in so that, the customer has the key.
Right.
Can't get the key.
We also have advanced rote 13 encryption.
Right. Actually,
Twice.
no.
Twice.
Basically,
Twice, yeah, we have it
Double
twice.
encrypted.
Right. We can do 0 more. One more question. Anyone? Want to be the last one? No? All right. Thank you very much.